I hope you all can hear me now, and we just will dive into our main topic. So the target audience for this session is software engineers and front-end enthusiasts, but not strictly for these two categories of people. Like everyone present here is welcome. It's just a passion that driving you is important for us, not the titles. So let's start by outlining the key objectives in this session. First and foremost, we will focus on understanding the importance of performance optimization in web applications. This is a critical area that can significantly impact user experience, search engine rankings, and overall success of the application. Next, we will dive into various techniques and best practices specifically tailored for optimizing Next applications. Whether you are just starting with Next or looking to refine your existing projects, these insights will be very much valuable to you all. And finally, we will explore real world scenarios where these techniques are applied, and also like we can understand how these optimization work in real world examples as well. And also like we'll give you some actionable knowledge that you can implement in your projects right away. So here's what we will cover today. So we'll start with an introduction, followed by a comparison between React and Next, exploring why Next is preferred and why performance optimization matters right now. So next, we'll talk about React and Next optimization techniques to help you boost your app's performance. And then we'll dive into key strategies like choosing the right rendering pattern, using built-in components and dynamic imports. We'll finish with some final takeaways to recap the most important points. So let's get started. So first, I would like to show you a video. It's a short video, like from a 1 hour long documentary about the evolution of React. It follows a small team, which is a core React team from Meta headquarters. So they dedicated to developing a solution to enhance Facebook performance, and how it then exploded onto the development landscape to become one of the most widely used libraries in the whole front-end landscape. So let's check this video.
Okay. Testing, 1, 2, testing.
Facebook was one of the first big products that was really an experience more than anything else. And as such, the user interface itself needs to be really pleasing.
The product itself got more complex, and as we added more engineers to the team, we didn't hit a wall, but it started to get really, really hard to make changes. That was around the time that Jordan was on the ads team, and he's like, there's gotta be a better way.
Hey, wouldn't it be easier if anytime anything happened, API state changes, user types something, we just blow away the entire UI and we re-render all of it?
It was so far outside of everybody's idea of how things should work and do work. Yeah, it took a lot of convincing.
Honestly, I thought it was completely crazy. There was no way that was gonna work.
I still remember like this wow moment when I actually tried it and like it actually worked.
It's this great example of this like underdog technology within a big company where there could have been these forces that really pushed back on it. So it felt like this very indie Rebel Alliance type of project.
If you want to spread an idea, you need to really convince a few people and have those people share your message. You can't just be shouting it yourself.
We started working on a JavaScript library that helps us do that, and we call it React.
It turned into a bit of a troll fest for no good reason.
I don't think that it was clear that it was going to become a popular project. To be honest, I think that it very easily might not have been.
I like React's story though, because it's like, it was a slow burn. Yeah, it's a real slow burn.
So basically, this video is from a channel called Honeypot. So they used to produce and direct these documentaries about cool tech stacks. There's a video for like Node.js, Kubernetes, and Vue.js also, I guess. So during your free time, go and check it out. Like it's worth your time actually, because who won't like to see what happened in the behind the curtains of like when your tech stack is being developed in a 4x4 room by few peoples, but it just made the front end ecosystem more popular. So yeah, go and check it out. So we'll go to the next slide. So next slide is about a comparison between React and Next.js. So speaking about React and Next, actually React and Next are not competing with each other, not at all. Next is a framework which is fully built on top of React library. Without React, there's no Next. Next is opinionated on routing, choosing pattern to render, data caching, and a few other things. But both the tools are open on the matter of state management. Because Next is opinionated, but not so opinionated like other frameworks like Angular. It let the developers take a few decisions based on their scale and requirements of the applications as well. So when it comes to state management solutions, there are like many state management libraries out there, like Redux Toolkit, MobX State Tree, Recoil, Xstate, and many other libraries out there. But we as Next developers or React developers can choose any solution we like to incorporate into our applications. We are not limited with the solutions from the framework, the opinions of the framework. That is the beauty of Next, actually. So you all will have this question, right? Why Next.js? Why not some other technologies, right? There are a couple of reasons to have Next.js and do a webinar on Next.js and its performance optimization techniques. They are like Next.js is a powerful framework of React, where both the tech stacks are highly used by the developers. According to one of the surveys from Stack Overflow, 42% of professional developers use React as their main tech stack to develop web applications. 17% of professional developers use Next.js as their main tech stack, and it's surging in popularity. Like it will be the top in the charts very soon. And when we take the companies that are using Next.js in their real world applications, as you all know, like adaptations of new tools are successful if people start to use it, if big companies start to use it. These are the well-known business entities which use Next as their main front-end tool in their live production websites. So when we take streaming services, like which needs like massive performance capabilities, right? Since it's rendering video content, much bigger video content than other websites and web applications. So when we take HBO Max and Hulu, so they are using Next.js, and video-based social media platforms like TikTok, e-commerce sites like Nike and Target, ticket booking platforms like Ticketmaster, music streaming service like Spotify. So this shows that Next can have loads of images, videos, and audios with any number of textual content. And also it is powerful enough to provide an optimized solution at the end of the day. So that's what the companies and developers need, right? And when we talk about these topics, like why performance optimization is important, like if you take enhanced user experience, like a faster, a more responsive app leads to a better experience for users, making them more likely to return and engage with our product. And also like optimized performance can directly impact conversion rate of the application as well. So if the traffic of the application goes high, the companies can make more money. And also the company has to use a perfect technology like Next.js to have a better user interface and user experience to get more traffic. So like making a purchase or signing up when the app performs well. So these actions has to be very fluid when it comes to choosing a front-end tool. And also search engine favor fast loading websites. Performance optimization can improve your SEO ranking, helping more users to find your site. Basically, if you take search engine optimization, search engines like Google and other search engines use web crawlers and web scrapers to go into the World Wide Web and crawl and scrape these websites URLs. So what it does is like it goes to the URL and just scrape all the content there, and it index those content. So when we search some words or some phrases in the search bar, it just search its own index database, and it gives the sites which is somewhat related to the search phrase of ours. To help the search engines to do better SEO, we need to have better performance optimized web application. Then only while the scrapers and crawlers are crawling and scraping the website, our site won't be in loading stage. It will be fully rendered, and it's a fully fledged website. So the search engine crawlers can get all the data and index it. Then optimized applications often require fewer resources and lesser server capacity, which can reduce the operational cost of the business entity as well. It is a major factor when deciding the profit and profitability of an application as well. And also a well-performing app stands out in a crowd market. We all know that, giving you an edge over competitors who might not prioritize optimization. So companies would like to do optimization, and they like to invest money on optimization strategies of the application to get a high uptime and high traffic for their application. So in summary, performance optimization isn't just a technical concern, it's a critical factor for user satisfaction also. Business success and staying ahead in the competitive landscape really needs these performance optimization techniques. So now we will move to the React optimization techniques. These are the optimization techniques that have been used by the React library right now. So like these are the well-known optimization techniques. These techniques can apply to the Next code base as well, since Next is basically React, nothing lesser than that. It just React.js with additional batteries, I would say. So we have techniques like virtual long list. So it shows only the list of elements which are within the viewport of the device. So we don't have to render all the images or all the video content. We can only render the needed elements of the list. So when the user scrolls up and up, those elements in the list will be loaded automatically. And lazy loading of images. So delay image loading until they enter the viewport to improve initial load time. So what happens is, what makes our web application or websites be slow is like heavy loads of JavaScript and images, videos, and other visual content. So what we have to do to mainly optimize the performance of an application is reduce the load of JavaScript by bundling the JavaScript and optimizing and compressing the JavaScript. And also, when we take the images, we can compress the images and render it as well. So also like we can apply code splitting techniques, like splitting the expensive code blocks as separate components and lazy loading it with suspense will increase the initial load time and gives the first byte to the user ASAP. Like, so splitting the components into a smaller part of components and loading it when needed into the code base is an essential factor in optimizing the performance. And memoizing the costly functions, what it does is it optimizes performance by avoiding unnecessary re-renders. What happens regarding the memoization function is React is working on a compiler right now. It was called as React Forget compiler. So after the advent of React Forget compiler into the developer landscape, so we don't have to memoize any type of functions. So React compiler will do that automatically for us. So until that, we have to use these memoize functions to memoize the expensive components and functions right now. And also we can use hooks like use transition and use default value to manage state and prioritize rendering for better responsiveness. Also, like we all know that React is based on JavaScript runtime. JavaScript runtime is single-threaded. It is not multi-threaded. So when we do an action, we can only do that action. We can't do parallel actions. We can only do concurrent actions in React. So to offload heavy computations to separate thread, to basically run another action parallelly with our applications, we can use web workers. Even though it's a separate topic to discuss, using web workers also optimize performance in React. Now we will look into each of these topics separately in detailed manner, because these topics are the key topics that we are going to look into today, because these are related to Next.js optimization techniques, which cannot be applied on a React code base. We need a Next.js application to apply these three techniques, such as choosing the right rendering pattern, using built-in components, and dynamic imports. Under choosing the right component, right rendering pattern, there are like 5 rendering patterns we have. Those are like client-server rendering, server-side rendering, static site generation, incremental static regeneration, and React server components. We have these small abbreviations like CSR, SSR, SSG, ISR, and RSC, which have been used in developer communities to easily identify these concepts. So first, we will look into this concept called loading. So loading a website is a crucial factor, because because it needs support of a server and the client web browser to serve and render a website fully. There's an in-between time when the user have to wait to see the website. The in-between time can be a few seconds to minute, depending on the site. So there's a thing called Web Vitals. So Web Vitals is a key thing set to key performance metrics introduced by Google to measure and enhance user experience on websites. They focus on aspects that directly affect how users perceive and interact with the site. Like there are like 6 main Web Vitals. Those are called as largest contentful paint, called LCP, first input delay, called FID, cumulative layout shifts, called CLS, and time to first byte, called TTFP. And the 6th one is like first contentful paint, called FCP. So these 6 Web Vitals are very much important to render a perfect applications without any loading. So basically, we need to understand these 6 Web Vitals, then only we can try to understand these concepts in a clear way. So when we come to client-side rendering, that's the first rendering pattern that we are going to discuss about. So CSR is a main technique that is being used by all the applications right now. So it is like a default rendering technique that is being followed right now. If we take CSR, so what happens is in the build phase, the website is built as a single page application with Next. The server typically sends a minimal HTML file along with JavaScript bundles, and the browser downloads and executes the JavaScript, which dynamically builds the content and interacts with the APIs to fetch the data. This can lead to slower initial page loads, but provides a highly interactive experience to the end user. These applications that have been made by using client-side rendering are called as single-page applications, because there'll be only one HTML page, and we will use the styles and JavaScript to mainly populate the content and show the website to the user. And our next pattern is server-side rendering. Server-side rendering is it's basically run on the website. Like on the build phase, what happens is the website is built so that HTML pages are generated on the server. For each user request using frameworks like Next.js or Next.js, the server will render the application. And the server processes the request, generates the complete HTML for the page, and sends it to the browser. The browser receives the fully rendered HTML, which leads to fast initial loads time and better SEO. As the content is already available, when the page is loaded, so what happened behind SSR, server-side rendering, is server sends a fully rendered HTML page to the browser, which displayed immediately on the user's applications. So it gives a sense to the user that the application is loaded very fastly, because the first byte to the user is sent as soon as possible to the client side. So it gives a sense to the user that applications loads without any issues at the end. And our next pattern is static site generation. It's called as SSG. The website, what happens in build process is the website is built by pre-rendering pages into static HTML files at build time using tools like Gatsby or Next.js with static generation. And what happens in server side is during the build process, the server generates the HTML files for each page that are stored and served as static assets. And in the browser side, browser requests the static HTML file from the server or a CDN, leading to a very fast load time that the content does not need to be dynamically generated. So it's a benefit out there for the end user because like end user can see the content as early as possible, like SSR. SSG is also like a modern rendering technique which helps smaller business entities to like render their particular websites and web applications. The next rendering pattern that we're going to look into is ISR. It is an offshoot of SSG because it is called as incremental static generation. What happens is similar to SSG, but allows for regeneration of static pages after the initial build. So on the server side, the server serves static pages initially, but can regenerate and cache specific pages also. So like on demand or at intervals as traffic or content changes occur, these pages will render, so build, render, and will be returned to the client browser. So on the browser side, the browser receives pre-rendered static content quickly with the option to update pages incrementally as needed. So without rebuilding the entire site, the new changes can be taken time to time from the server. So while getting the new changes, the server will rebuild the site and send it to the web browser that is a client. But the content also can be updated time to time, and we can save the performance also. And we have to do only one thing. We have to pass a parameter called revalidate with a number for the milliseconds to like revalidate the whole content and build and deploy the content on the web browser. That's the one only like the user side code change that we have to do. And the next and the main rendering pattern is React Server Components. Because React Server Components allows the use of server-side rendering for parts of the React component tree. So you will get a doubt like what is the difference between SSR and RSC? Means like server-side rendering and React Server Components. The basic difference is server-side rendering side, we have to render only the first page, the foremost page in the page tree. But for the React Server Components, we have to build and render only the components available on the web applications. So enabling a mix of server rendered and client rendered components. So on the server side, server components are rendered on the server and sent as HTML, which client components manage interactions and dynamic behavior on the client side. On the browser side, the browser receives HTML from the server for server rendered components and JavaScript for client-side components. So for the server components will be packaged as HTMLs and client components will be packaged as components with HTML, CSS, and JavaScript, as similar to what happens in a CSR. So balancing initial load performance will be done for the interactivity purpose here, but all the other things are like same here. The main thing here is like React Server Components are beneficial in a way because like since it's a modern technique, it gives us a benefit to select which components can be rendered as server components and which components can be rendered as client components. So it's a perk here. So we can choose what components are going to server and what components are going to client. The components which are highly dynamic and highly need user interactions are going to client side. And the components, it doesn't have interactions, it just consists images and text can be sent to server side, and we can optimize the performance using those techniques. And next, we are going to see like previously we spoke about all the rendering patterns listed on the previous slide. But here we are going to see the real world business use cases for those rendering patterns, because like there is no technology that is not being used like without any business perspective. Like business comes as a vital thing to empower anything, right? So the rendering patterns on the left has the business use cases on the right. So when we take client-side rendering, single page apps like Gmail and Facebook like were using client-side rendering previously. And I guess right now Gmail is still using client-side rendering. Facebook also using client-side rendering, but it is moved to server components also. Like it is mismatching the rendering patterns according to its business use cases. When it comes to server-side rendering, SEO crucial sites like Amazon and Daraz are doing well in server-side rendering. It's because the need for server-side rendering comes with the higher position or the top position in the search result page, because we won't like if we search a phrase or a term in the search engine, we won't even look into the second or third page from the search engine, right? The results of the search engine. We just click the first few links and then we go and search for another term. So SEO is a crucial thing for e-commerce sites like Amazon and Daraz. So they primarily use server-side rendering to like get the most out of SEO ranking. And in static site generation, static content sites like advertising and marketing sites are mainly using the SSG technique because they don't have to interact with the user. They just have images, videos, and textual content that has to be shown to the user. And the user is like, there's no need for users to interact with the application. There are no heavy forms, there are no heavy computational tasks done for them. So they can easily build the site once, and they will rebuild the site when there's a change in content. That will be like 1 or 2 months or like more than 3 months. Then we can come to incremental static regeneration techniques. So it's mainly used in news portals. So basically, the Washington Post is using Next.js to empower their web application. They are using incremental static regeneration because like they have to revalidate the content like within like 1 minute or 2 minutes or like 3 minutes, like after new news articles have been posted on their site. So it's a good technique to use for the news sites. And the last but not the least technique is a React server component. It is the best technique out of like 6 techniques because like 5 techniques, because like it is built only for complex enterprise applications, because we can name a component as client component and ship directly to the browser, or else we can name the other component as a server component and we can ship to the server, and server will build and render the whole server component, and it will only gives HTML as the output. So browser doesn't need to run a heavy JavaScript functions to get the HTML out of that. So it's a plain old HTML. So it just saves more performance at the end of the day. So my next slide is with the built-in components from Next.js framework, because there are many frameworks which are offering these rendering techniques, right? But there are only few frameworks that are offering built-in components to increase the performance of the application. So basically we can name Next.js is one of them. So in Next.js, next image component is a wrapper component of the HTML image element. Why a website takes more time to load on a browser? Because of the images, right? So Next.js have created an image component to optimize the images and increase the performance. So it gives techniques like automatic optimization. So basically, automatic optimization is one of the good techniques from Next.js image component, which automatically optimizes the images based on the device size and resolution. This ensures fast loading times and a better user experience. And when it comes to lazy loading, images are loaded only when the component into the viewport. When the image component comes into the viewport, only the images are being loaded. Until that, the application won't load the image, because sometimes for many times the users just leave with first 3 images, right? They won't even be interested to look into the last 5 or 6 images that are not in the viewport of the device. So we don't have to load it. When the user is interested to see those images only, we can sense we have to sense his scrolling actions, and then we have to load those images. And then there's a technical responsive images. So we can pass a prop call layout, and the prop will allow us to choose from different strategies for responsive images, such as fill, fixed, intrinsic, or responsive images as well. And the last technique from Next image component is automatic image optimization. Next.js optimizes images by serving them in a modern formats like WebP, which is a very much optimized format. So generating multiple sizes for different resolutions of an image will helps the application to optimize a whole site in a better way. So next we'll move to the link component that is being used from Next Link API. So what it does is it prefetch links. There are many benefits are there after doing the links prefetching, because a link component prefetches linked pages in background, providing high performance navigation with minimal delay. So this results in a faster page transitions and enhances the overall user experience. And we will have SEO benefits as well, because a preloading feature helps the search engines to quickly crawl and index the entire navigation structure, improving SEO implementations and visibility in a greater way. And also the last point is smooth client-side navigation. So we will benefit from Next Link component by getting a smooth client-side navigation. Unlike traditional anchor tags, the link component enables navigation without complete page transitions. So it maintains application state and provide a smooth experience across the application navigation. The next thing that we are going to look into is a font component from Next Font. So there's no external network request to get and load the font in the web browser. So Next already have optimized fonts in its library, like Google fonts are already available in Next. By using this Next Font component, we can use those fonts. Next Font will always optimize the fonts, including the custom fonts that we can configure in the Next Font import. So by removing the external network request, we can use those Next fonts. And also built-in automatic self-hosting for any font file. This means you can openly load the web fonts with zero layout shift, thanks to the underlying CSS size adjust property used here, because it will automatically change the font sizes based on the resolution of the devices as well. And there's a support for multiple fonts, so we can able to preload and optimize multiple fonts to use in the app. It is kind of a very good feature, because loading and configuring multiple fonts might take more capacity from the machine, and more memory usage will be there. So we can optimize these things using Next Font component. And the last component, built-in component from Next.js is Next Script. So what happens is we can fine-tune loading behavior using the script component. So it is a strategy property which is available in the Next Script component. So we can use the strategy property to load any script before interaction, after interactions, and also load the script when it is visible on the viewport. Additionally, we can load the script on the web worker as well, which is a handy feature to reduce the load time and increase the performance. Also, it can be handy when importing scripts for web analytics and engagement measurements like scripts like Hotjar and Google Ads. So we don't have to dump all the scripts inside the head tag. We have this next script component. Like if there is like 10 pages out there and only 2 pages need this script, so we don't have to load these third-party scripts in the other 8 pages, right? We just have to load in the 2 pages of ours. So what we can do is we can import this next script component and we can load those third-party scripts very easily by saving performance. So the next topic is like technique is dynamic imports. So what is dynamic imports? Like dynamic imports is a feature that allows us to load JavaScript modules asynchronously. In the context of a Next.js application, like this means we can load components on demand rather than bundling them all together at the initial page load. So basically this can lead to smaller JavaScript size bundle sizes and faster page load times, enhancing the overall user experience. And also like initial load times will be reduced to half because we don't have to load the very expensive component at the initial load time, even though it is existing in the initial page of the web application, because we can lazy load it and we can use fallback components to show a loading screen or the loading spinner or just like a skeleton. So the users will be looking for a component. At the same time, users can interact with the other already loaded, means preloaded content also. So they don't have to wait for the loading of this expensive component. The benefits are like faster page loads. There's like initial bundle size is very low, resulting in a quick build time and page loads. And also we have better SEO. Like if the page loads as soon as possible for the web crawlers to crawl the site, there will be better SEO, right? But we have downside also. Like the downside is each dynamic imports will trigger additional HTTP requests, which might affect the performance as well. So we have been advised to use this specific component economically. Like we don't want to use these components all the time. It depends on the purpose and requirement of the application. So the final takeaways from this webinar is, I would say, like we have found out that Next.js is a better solution to build performance optimized web applications and websites. And Next.js is widely being used by the companies out there, like famous ones like TikTok, Spotify. The whole Meta ecosystem is totally built on Next.js. Instagram has started to use the React compiler, which is in the testing stage, but they have been testing with the Instagram feeds right now. And it's a very I would say like Next.js has a very good feature in the front-end ecosystem. And I would say like, please go in and use it and try to build some small applications out there. So this quote is from a person called Seth Godin. He's a very famous writer, entrepreneur, and speaker. So the quote is like, be bold, make mistakes, learn a lesson, and fix what doesn't work. So that's basically like our job is to fix what doesn't work, right? So you don't have to keep on reading all the documentations and follow all the videos out there, video tutorials out there, because you will get stuck in a loop without doing your real coding. So do some practical programming, open your VS Code, create some cool web and mobile applications, get some hands-on experience by developing at least a small program like Hello World. So try to apply these performance optimization techniques that we have spoke about today, like see how it improves the web vitals and the overall user experience of the web applications as well. Also, it is better to know that good coding practices and optimization techniques are very essential to avoid the performance derailment of an application, and be open to learn, unlearn, and relearn the concepts and theories that you have in your mind, because it will open new windows to you. So improving performance is a endless journey. Like improving performance, it never ends, because as web developers, we rely heavily on servers and web browsers, right? Even though if we build an application on our own, we need the support of deployment servers and web browsers for the client to interact and use our applications. So we need to follow up the new techniques and new advancement that have been happening in web browsers. And basically, we are building the web application for the web browsers in relative to the web browsers. So the changes across these different entities will affect our site as well. Also, the web ecosystem is changing rapidly. So new improvements are vital to keep the site without downtime. Also, like new frameworks and new tools are like very much important and needed at this point of time, because it ease our development time and ease the developers as well. And it finally gives us a very good developer experience that all the developers dream of. So it's never ending journey. Be prepared and always keep you updated with the modern technological advancements out there. And we have come to the end of our session. Thank you very much for keeping up with the all the knowledge related to the Next.js performance optimization techniques. If you guys have any queries or questions, please ask. I'll try my best to answer it. Thank you for your valuable time. It's been a pleasure to share the knowledge with you all. And I hope it was a good session to know more optimization things about Next.js. And yeah, let's meet in our next webinar session soon. Thank you, guys. See you.